Hello viewers, welcome to my channel Connect Civilians. So in this lecture we are going to see how to apply a wind load on a steel structure. Okay, this is our structure and we have applied all the properties, and in the loading we have to add the load that is coming due to the wind. So 8 cases has been generated for the wind forces, that is from x direction, from 0 degree from this side. Similarly, for from 180 degree opposite to the x direction, from 90 degree, and from 270 degree. Okay, four cases will be there, and for the coefficient, internal pressure coefficient, positive and negative, we are going to calculate for both. So 8 cases will be generated. Okay, and also we have to apply for the roof also. So this is our structure, and here this is our purlin which is placed on the roof. Okay, and this is our after. So using the Excel sheet we are going to calculate the wind forces that is coming on the steel structure. So first we have to find out all the value that you have to insert for the calculation of your wind loads. So in blue boxes, if you see here, so these blue boxes you have to fill manually. After that it will calculate all the forces that is coming on the structure in all the directions. So in yellow boxes the value will be given which is used in Staad. You can also use in tab if you want. Okay, so first we have to mention our type of structure. So in clause 6.3.1, either you, if you want to use the IS code 873 part 3, so that will be okay. I will provide the link in the description, or you can download from my Telegram channel also. Or we have already inserted the important tables from the code, so you can directly see from the Excel sheet only. Okay, so here which first we have to open the Excel IS code. So this will be the code we are using, IS 1875 part 3 2015. So first we have to find the type of structure. So our is our basic steel structure for warehouse, so it will come in our general buildings and structure. It is mentioned on IS code clause 6.3.1 also. You can check from the code only if you want. Okay, so it will come in general buildings. If it is an important building like hospital or plants or power plant, so you have to follow the type of structure as 4, and for K1 value you have to calculate from this one. Okay, so our type of structure is 1. Our basic wind speed is 47 meter per second. It is mentioned in IS code at the last. Okay, on another is clock 6.2. So from here you can get the basic wind speed of the main cities, and if your city was not present yet, so you can follow the nearby city of you. Okay, so our is Agra, it is 47. That will be okay. 47 meter per second. Terrain category. So you have to find our terrain category. So these are the 4 types of terrain category, that is category 1, category 2, category 3, category 4. So here what you have to do. So our structure is coming under category 1, where the scattered obstruction will be present. So 4 categories were there. You can check out all the 4 categories if you want. I will show you the here on page number 5. See here. So category 1 is exposed open terrain with few or no obstruction. Okay. So here what will happen? Only a few building will be present nearby you, or no building is present, so it will come under category 1, where the height of the building is less than 1.5 meter. In category 2 what will happen? So few obstruction will be present. If I will rotate this figure, I will show you here. On category open terrain with well scattered obstruction having height generally between 1.5 meter and 10 meter. So we are going to follow the category 2 here, because there will be there were little bit of obstruction will present where 3 meter, around 3 meter and 4 meter building will be there. So I'm going to take the category 2. Similarly for category 4 and 5, sorry, 3 and 4 will also be there. You can also check. So category 3, terrain with numerously closely spaced obstruction. So it is nearby where the society will be there or multi-story building will be nearby your building. So you can follow category 3. Okay. Similarly for category 4. So we are going to follow the category 3. Sorry, category 2. Because few obstruction will be there in our building nearby our building. So category 2 we have chosen. So all category is present. You have to choose your category. It is 2. Now this will be okay. So risk coefficient or probability factor. So it will present on page number 7, clause 6.3.1. Okay. Page number 7, clause 6.3.1. So this will be our K1. So here it is coming in general buildings for which our life of our structure is 50. Here we are going to take. So K2 value will be, okay, it is K2. So it is our basic wind speed 47. So our K2 value is 1. Okay. So K1 is here. Okay, it is K1. Okay, this is K1. Okay, so it is 1. So here we have taken 1. Similarly, topography factor. So page number 8, it is present. Page number 8, that is, okay, here to minimize it for topography factor K3. So on page number 8, it is here. Here it is present. The effect of topography shall be significant at a site when the upward slope. So if its slope is more than 3 degree, so we can go with the higher value, but if it is less than 3 degree, okay, we can go with the topography factor as 1. Okay, if it is more than 3 degree, I will show you in another lecture how it is calculated, where the slopey area is there. So our topography will changes, so value for K3 is also changing, but here our topography is not like this. It is simple where the plane surface is there. So our theta will slope will be less than 3 degrees. So I am going with the value 1. Okay, generally it is 1. For hilly area the value will be changes. Okay, so here we have taken 1. And similarly important factor for cyclonic. So our area is not coming under the cyclonic region, but we can provide the value according to this. So 3 value will be there, either it is 1 or 1.3 or 1.15. So on page number, it is present on page number, I will show you, page 8, 6.3.4. So page 8, 6.3.4. Here important factor for cyclonic region. Okay. So if it is present in eastern coast of Gujarat or coast area, so there we have to change the value. Structure of post cyclonic region is 1.3. If it is industrial structure, it is 1.15, and for all other structure it is 1. So if our structure is in the belt of coast away from up to 60 kilometers, so we can go with the 1.3 and 1.15 according to our structure. But our structure is safe, it is in the mid of our state, so it is away more than 60 kilometers from the coast, so we are going with 1 value. Okay, so here it is okay. Also it is value is 1. So 3 value will be there, 1.3, 1.15 and 1. So I mention all the values, so according to you can select it. Okay, and for the tributary area dimension, what is the tributary area dimension? So if you go in the figure here, so this column to column distance is your tributary area. Okay, similarly here also the column to column distance is your tributary area. Okay, so I will suggest you to provide the column to column distance in all the direction at equal spacing, so that will be more easy to you to calculate the wind. Otherwise you have to calculate for all the tributary area values differently for different locations, okay, or directions. So here it is 10 and our height is 4, so 10 into 4, that is 40. So our height is 10 and column to column distance is 10 meter, so our tributary area is 40. Okay, so here we have not provided the same distance, but you can go with the same distance if you want. Okay, here it is 20 by 4, but from this side we are going to calculate first, so it is 20 by 10 by 4. So our tributary area is calculated as 40 and we have to use the interpolated value. So 40 will come, so on page number 10 I will show you, page number 10. Okay, so this will be our area averaging factor calculation. So for Ka value, okay, this value will be needed, and if your tributary area is less than 10 or equal to 10, so area averaging factor is 1. If it is 25, 0.9, and if it is greater than 100 mm or 100 meter square, so it is 0.8. And if the value is coming between these values, so you have to use the linear interpolation. So we have done the interpolation here. Our value is coming as 40, so 40 will come between 25 and 100. Okay, 25 100. So if you change this as 25, this value will be automatically changes. You don't need to change anything. So it is 0.9, 0.9, and it is 0.8. So our interpolated value of K will come as 0.88. Here it is taken. Okay. So if okay, here it is. Okay. Similarly for wind directionality factor KD, page 910. Okay, KD will be here. This will be your KD. Considering the randomness in the directionality of the wind and recognition the fact that pressure or force coefficient are determined for specific wind directions. Okay, so for the cyclonic effect also KD shall be taken as 1, and for the normal structure we are going to take as 0.9, that is triangular, square and rectangular. So our structure is rectangular, so we are going with factor 0.9. So here we have taken 0.9. If it is circular type structure, so we have to go with 1. Okay, so this will be okay, 0.9. Similarly combination factor Kc will be on page number 16. It is shown, page number 16. I'm showing you in the code only because you can also go through the code, because it was important. Without code you can't design any of your structure. Okay, you have to study the code. Maybe I am not able to apply all the factors, so you can go through the code also and check if I am right or wrong. Okay, on page number 16 you have to find the Kc value. So this will be Kc 7.3.3.13. So Kc here it is shown. See, when taking wind loads on frames of clad building, it is reasonable to assume that the pressure of suction inside and outside the structure shall not be fully correlated. Therefore, when taking the combined effect of wind load on the frame, a reduction factor of Kc of 0.9 may be used for the building. Okay, when roof is subject to pressure and internal pressure suction. So we have to apply the roof load also. So we are going with Kc as 0.9. Here it is 0.9. Okay. Similarly, you have to give the dimension of a structure. So greater dimension, that is length of a structure is, I think it is 70 meter because I have applied all the loads first already. So it is, let's see, okay, it is 70, the length is 70, width will be 40. Yeah, it is correct. It is 40 and our height is 4 meter. We have already shown you at the eave. Okay, not at the ridge. So ridge will be center and eave is the corner. Okay, so this will be okay. Our dimension will be okay. So, and now we have to give the, what is the our distance between the column in the two sides in 0 degree and 90 degree. This will be a 0. This will be a 90 degree. Okay, from here. Okay, so our column distance is 20 meter. I have already shown you. Sorry, 10 meter. So you have to provide the column to column distance will be in 0 degree 10 meter, and for 90 degree this will be a 90 degree, but here it is 90 degree. So 20. Why I am calculating for this? Because this is 0, 90, 180, 270. Okay, as per the direction. This is the shape. So this will be 0, 90, 180 and 270. Okay. So I will again repeat, just provide the column distance at equal positions. So if you are not going with the four side at equal position, just follow the two opposite sides. So this uh, 0 degree and this will be 180 degrees. Follow the column distance as same. Okay. Similarly for 90 and 270 degree. Okay. This will be 20 meter. So this will help you to calculate the wind load on the individual members, that is on individual columns. Okay, and your terrain and height multiplier will be calculated here. So on page number 8 I will show you. On page number 8, it is a quite a bit complex, that's why I am showing you step by step so you don't need to be confused. Okay, on page number 8 it is showing. So 6.3.2, 3.2.2. So our height of the structure is less than 10 meter and our terrain category is 2, so our value is 1. So this is 1. Here it is taken by automatically by itself, you don't need to change any values. Here wind pressure is calculated, so our height is 10 meters, so you have to follow the PD value from here. If our height is more than 10 meter, that is 15 meter, you have to follow this. So you have to change by yourself. Okay, generally the height of the steel structure or the warehouses was not greater than 10 meter, but in any case it is. So what will happen, you have to take the value from here and you have to change the PD value in this. I will show you how it is calculated from here. Okay, and maybe your intermediate is coming, that is your height is 12 meter. So what will happen, so for 100 meter we have calculated, to the height of 100 meter we have calculated, and this value is used in the interpolation. So you need to just copy the formula and place between which value your height is coming. Example, so your building height is 12 meters, so what will happen, it will come between 10 and 15. You have to insert the row here. Okay, so I will provide the both the two excel sheets, that is the uh, first one is your unprotected sheet and second one is protected sheet. So both you can download. If you want to change the value according to you, you can go with unprotected sheet, and if you just follow the same process, you can follow, just take the protected sheet and use the value 3. Okay, so now it is calculated and your PD is coming at 0.94. Okay, okay, this value is okay right now, and now we have to take the check the other our in our structure opening will be there. So according to the opening you have to provide the exposure factor. Okay, so internal coefficient is provided according to the opening only. Okay, so I will show you in the code. See here. Clause 7.3.2. In the case of building where the cladding permits the flow of air with opening not more than 5% of the wall area, but where there were no large opening, it is necessary to consider the possibility of internal pressure being positive and negative. So, for if it is our opening is less than 5%, you have to consider the internal pressure coefficient as plus 1, 2 and minus 1, 0.2. Okay. Similarly, for the building with medium and large opening, if it is between 5 to 20%, you have to consider plus 0.5 minus 0.5, and if it is greater than 20%, you have to consider plus 0.7 minus 0.7. So in our structure, opening was not there. Okay, but for the ventilation purpose, maybe opening will be provided. So we will consider the opening less than 5%. Okay, so we have taken the opening as 40%. So according to that, you have to consider your internal pressure. So it is taken by software according to opening. So percentage opening is 4.55 and exposure factor 0.95. Okay. So here it is. Our external and internal pressure coefficient will be H by W ratio is 0.1, L by W ratio is 1.75. So this ratio will help you to calculate the internal external pressure coefficient. Okay. And CPI value internal pressure coefficient is calculated as 0.2 at opening is less than 5%. Okay. So I will also show you the figure. Maybe assume that one side of opening is greater than 5% or more than your required, that is 0.8 from one of the sides. So what will happen? You have to take the opening of that side or the maximum opening of the sides. Okay. Okay. So if it is 0.8, you have to provide according to that. Here it is 0.8. So here it is 0.5. So opening will be provided here, and if wind is flowing here, so it will be go inside toward the structure, that is positive coefficient, and from this all this side it will go away from the structure, that is negative coefficient. Similarly, if wind will flow from here, it will be positive and this will be all negative. Okay, similarly all the procedure will be followed. And assume the one from one side of opening is less than 5%, so that will you can take the coefficient internal pressure according to that, and from 90 degree on another side it is more than 0.8, so you have to follow that also. Okay, the maximum one, or you can change your CPI value in this table by manually also. Okay, I will show you how it is changes, but for now it is okay because our opening is 40%. So our CPI value you have to check from the table. So this will be your table for the external pressure coefficient. So our H by W is coming as 0.1, and it is H by W is if it is less than 1.2, that is 0.5. So this will come in this, and there will be two options more for building param ratio. So our ratio will for L by W is 1.75, W is the width and L is the length. Okay, so 1.75 will come as, so first is L by W is greater than but less than 0.1.5, I think so. So our structure is come between this. L by W is greater than 3.2 but less than 4. So our is L by W ratio is coming 1.75 is greater than 1.5. So you have to follow this table. Okay. Now what will happen? So this is the plan of the structure. Okay. And this is the directions A, B, C, D. So we have made the table for this A, B, C, D according to the calculation. Okay. So it is ABCD and our angle will be 0 degree and 90 degree. So we have made 0 degree and 90 degree. You have to fill the 0 degree value here, 90 degree value here. So our 0 degree for A will be plus 0.7, for B will be minus 0.25, for C minus 0.6, and for D minus 0.6. So 0.7 minus 0.25 minus 0.6 minus 0.6. Okay. Here it is. Similarly for 90 degree, it is minus 0.5 minus 0.5 plus 0.7 minus 0.1. Okay. So minus 0.5 minus plus 0.7 minus 0.1. Okay. So this is correct here, and according to that, it will calculate your uh, CPE value for 180 degree and 270 degree. That is 180 degree this and 270 degree will be this. Okay. So code will give you only the two direction values. You have to calculate according to this. So we have arranged this value according to this. All you need to do, you have to fill the 0 degree and 90 degree value and it will calculate it. So first we will check for the directions of wind flowing from the x and z directions in the Staad. Okay, this direction and z direction. Okay, so now if you will see, we will first check the load in the lateral directions. Okay, after that we can check for the roof also. So when wind will flow in 0 degree with positive sequence, that is from left to right. This will be a left, so wind will flowing from this direction to this direction. Okay, here we have also added the plan. Sorry, plan and elevation. This will be the plan and this will be your columns. So what will happen? How wind will flow from 0 degree to and in positive with positive CPI from left to right. So this will be a 0 degree. This, so wind will flow in this direction. Okay, and this will be your elevation of the structure. So this is not the elevation. This is the view. Okay, 3D view. So this will be A, B, C, D. Simply in plan A, B, C, D. So in this type you have to provide the values. Here if you see A, B, C, D. So now if you see the code, here it is. Our forces value will be coming as. So this will be for positive CPI, value will be taken from here only. And one more thing I will add, that is minus sign will show you the direction only. It will not be used in the calculation. Always remember this. Okay. This minus sign is showing only the direction and this minus sign is only showing the direction. That is, if it is negative, so it will be acting away from the structure, and if it is positive, so it will act towards the structure. Okay. So when wind is flowing from 0 degree with positive CPI W1, how will be added? So here it is, force will be coming as 4.72 minus 4.25. So A will be coming here. So we have added here the loads. So this will be your 4.72. We have added the load. So how it is coming? See the blue one. So it will be acting in column in the positive towards the structure. Why? Because our force is positive. So if it is acting positive, I will show you here. So you have to apply the load 4.72 in the direction of x, because it is acting toward the structure in global GZ direction, x direction, in this direction. Okay, and after that you have to select these columns. Either you want to select it from the elevation or from the section, and assign to selected and assign. Okay, so you already assigned, so we are not doing it again and again. Okay, and so for the middle we have to use the full value, because half of the load of this wall is transferred here and half of the load of this wall is transferred here, but at the corner you have to take the half of this value, that is 4.72 half values. This is 2.36. So here we have taken 2.36 on this column towards the structure and this column towards the structure. Okay, similarly for B. Okay, this will be your B, and this is the B. So what is, so this will be A, this will B, this will be C, and this will be D, I will show you in the plan also. A B C D, A B C D. Okay, do not forget the numbers. Okay, the directions, do not forget about the direction, from where direction, which direction it is applied, and it is mentioned in the code. Okay, A B C D. Okay, so we are following the code only, and it is coming as negative minus 4.25. So what you have to do, you have to apply the loads away from the structure. Okay, so direction of this, if you see here, see, it is going away from the structure, it is not acting towards the structure from the outside to the inside. Okay, so it is 4.25. Why we have taken the positive value here? Because instead you have to, if you are applying the loads away from the structure from in this direction, uh, x direction, you have to take the positive value. If you are taking in minus x, you have to take the negative value. Okay, so here we have taken the 4.25 and applied here. Select these columns again, all the columns in the similar way, and you have to apply the loads according to that. Okay, and similarly for the corner column, we have applied the half of the loads on both the columns. In similar way, you have to apply for C and D. And C and D, your A will be changes because your column distance is different, that is 20 meter. So value will be coming more. So at the mid column, you have to apply C 15.2. C will be this, and if it is negative, so it is applied away from the structure, that is outside the structure, so it is applied there. So 15.25 for D also it is taken, and it is also minus, it is going away from the structure, but here to provide the positive value in z direction, and as per star it is going outside. Okay, towards the z, positive z. So to get 15.12, and for the C value, that is minus 15.12, similar value is there, so you have to provide negative value, it is going opposite to the z direction. Okay, and for the corner column we have to again half the value, that is 15.12 divided by 2. So similar value will be applied here also and here also. Okay, and if you see the in similar way, you have to apply the loads for all the direction. So this 0 degree will be applied here, and for the roof also, if you want to check. So here is that calculation for the roof. So total height at the ridge, that is at the center of the building, this will be your ridge. Okay, so total height from bottom is 5 meter. Height at the ridge center will become as 1 meter. Okay, height at the corner will be 4 meter. Width up to the mid will be 20 meters. This value is coming when roof angle is calculated as 2.9 degree. So from the code, so we will go to the code here. External pressure coefficient for pitch roof or rectangular clad building. Okay, so if h by w is less than or equal to 1 by 2, so our h by w value is 0.1, so this will be okay. So it will coming in this, our angle will be coming at 2.9 degree. So this will angle will come at between 0 and 5. Okay, so here it is 2.86. Okay, that will be okay, value from the table, this table only. And so you have to insert this above and the bottom value, that is degree 0 and 5, because our degree is coming between this. So 0 and 5 you have to insert by yourself, 0 and, okay. In similar ways, for if you have or going with the angle, that is EFGH and EGFG. What is EF? If you see the plan, this plan, this will be EF and this will be GH, and it is divided into two parts, and after that four parts will be equally divided. Okay, so for EF, for 0 degree it is 0 minus 0.8 and minus 0.9. If we change this to okay, Okay, I will select it. Okay, now it is changes. So our value is minus 0.8 and minus 0.9, minus 0.8 and minus 0.9. Okay, so your interpolated value is minus 0.86. You have to fill here in EF because we are calculating for EF. Okay, so minus 0.86. After that, for GF, so our value for GF is 0. Minus 0.4 minus 0.4. So our interpolated value will be minus 0.4 only. Okay, minus 0.4 will be there. So you have to fill here. Similarly, for 90-degree EGFH, you have to fill here. So for EG it is 0.8 minus 0.8 minus 0.8, and for FH minus 0.4 minus 0.4. Fill this value and you will get the result, and you have to add the result here. Okay. Now for 180 and 270 it is calculated from here only. So it will be automatically calculated here. This will be okay. And for roof, for the wind, when wind is flowing from in 0 degree positive CPI, so EFGS value will be 10.1 and minus 5.6. Okay, so it will be applied. It is in minus, so it will be applied away from the structure. Okay, so you have to hide 10.1 because it is away from the structure, so it will going upward in y direction. So you have selected y and will be upward, so you do not need to add minus sign. Close and just select your uh, rafter, sorry, like this, and apply, or you can select from the plan also, like this. Okay, so all will be calculated and assigned to selected beam assigned. Okay, similarly for the second part you have to do, that is for GF. So EF will be this side and GF will be this side. Okay, so GF will be this side and we applied here in same way. Our value is coming at minus 5.64. So our forces will acting away from the structure, that is upward. So we have applied. So in similar way you can apply the load to our structure from all the directions. So 8 loads category will be defined, and for both for all the 8 loads you have to fill. So this will be 0 degree positive. So for W2 will be 0 degree negative. W3 will be, sorry, when wind is from 180 degree, that is from right to left. So in this category what will happen, so your wind will flow from this side, so this will come as toward the structure, this value come off as positive, and all the value will be negative because all the value will go up away from the structure. So this will be your B side, so B will be only positive. Okay, all will be negative. So this is also the one of the method you can check either you are going correctly or not. Okay, you can go with the this value also when wind is in 0 degree with negative CPI. Okay, so what will happen, it is acting from this degree only, but your internal pressure coefficient is opposite to the structure. Okay, so here what will happen, your B, C and D value will come as negative, and your A value will be positive because it is acting toward the structure, and all the value will go outside the structure. Okay, so your A will be positive and all the value will be negative. Similarly for 90 180 degrees, similar will be taken for from 180 degree when it is acting towards the C. So what will happen, your C value will be positive and all the value will be negative. C value will be okay here, this one. Okay, this is B. So B value will be positive, A, B, C, D, and all three value will be negative. So B is positive, all three value will be negative. Similarly, when wind is acting from 90 degree, so this will be a 90 degree. So what will happen? This will be A, B, C. So C will be only positive, and all will be negative. See here, C will be positive and all value will be negative as it is going outside the structure. So in similar way you can check this also either it is correct or not. It is going toward the structure or away the structure. Or the direction will be there. And for the roof also all the value will be present. You can just put the your initial values in the calculation and you will find the result. Okay, and apply as I am showing you. Okay, for all the wind loads in different direction and for the roof also. And one more thing, if your opening is different in different direction or different sides, so you can calculate it by changing your CPE value from here. Okay, or you can just insert your maximum opening if you want. Okay, but correct way you can, where your percent of opening on the side is given, you get to calculate according to that and assume that for A side it is 0.2 and for B side it is 0.1. So you can change the value here also if you want to. And one more thing, here your CPE is greater than CPI, so your value will be showing is correctly because we are subtracting the value. But in any case, that is your CPI value will be 0.8, that is opening is more than 20%. So what will happen, you have to subtract the highest to the lowest, so this will not work. Okay, so I will provide that excel sheet also where you can change manually all the values. Here what we have done, we are subtracting the larger to smaller value as CPI value is larger and CPI value is smaller. But in case where your CPI is greater, so you have to again subtract the value from larger to smaller. And this minus sign just only denotes your the direction. It is nothing. Okay, you don't need to add in the calculation. Okay, so always remember that is the positive sign will maximum value will be used for the subtract. So maximum value will be used for the subtraction and you have to subtract the value from maximum to minimum. Either it is CP or CPI. Assume here one of the values is there, that is for the our CPI value is 0.1, ignore the minus sign, and CPI value is 0.2. So what will happen? Here our CPI is greater, so we have to subtract the CPI minus CPE. Here we have done ABS E75 minus ABS E76. That means your 0.2 minus 0.1, it is coming as 0.1. Okay, and minus value is only showing for the direction. Okay, so always subtract the highest to lowest value. Okay, either it is CPI or CPI. So this table work easily where the your CPI value is less than CPE value. But in any case, it will happen that your CPI value is greater. So what you have to do, you have to subtract the CPI minus CPE. Okay, how we have done here. So you can check from this table also, and we will provide the one unprotected sheet also. You can download it and you can change the value according to you and according to the percentage opening your structure is there, and all the value will be applied in the Staad, or if you want to apply it in each tab you can go for it also. Okay, but in this tab it is more easier and it is calculated by itself, but for more accurate results you can follow the course and these values, this excel sheet, so it will help you to design. All the plan will be showing and this figure will also guide you how the load will be applied. See here, this direction is showing that your external pressure coefficient, that is force, is acting towards the structure. So this will be positive value, and this value is negative, so it will going away from the structure. So this will be internal pressure coefficient, that is 0.2. This is positive, so it is acting towards the structure. If it is negative, it will act away from the structure. So arrow will be in this direction, so positive directions. Similarly here also it is same negative, so away from the structure, and positive towards the structure. Okay, so this diagram is made to understand how load your uh, direction will be used in this, in the software also. Okay, and this will be your reach, this will be your directions. Okay, if you want to download this, I will provide the link in the description, or also provide in our Telegram channel. You can download it from there only if you want. So if you like this video, please subscribe to my channel. I will also come with the total series of your steel structure in future. Okay, thank you.